first part of this review covers is over things that we covered in Chapter 4. This is your practice exam, and these are the solutions. The document without the narration is available or will be available on the website in addition. So the first question says, in updated results from a test of Microsoft's XSort gender selection technique, 726 births consisted of 668 baby girls and 58 baby boys. Based on this, what's the probability of a girl born to a couple using this gender selection method? And the probability of a girl is the number of ways you can get a girl, which is 668, divided by, or the number of girls that were actually born, divided by the number of births. And so that's 668 divided by 726 is approximately 0.92. The next question I went over in class, and those solutions might be useful to you, but I'm going to go ahead for the sake of economy. I'm going to go ahead to this one with the gumball machines because it is most like the question on the test. The question on the test deals with M&Ms. So we have a gumball machine with 20 gumballs in it. 6 are red, 3 are green, 5 are orange, 2 are blue, 2 are pink, and 2 are white. If one gumball is selected at random, what's the probability it's orange or blue? Well, there are 5 orange and 2 blue, so that means that if we add 2 to 5, we get 7, so there's 7 gumballs that are either orange or blue, so that 7 divided by 20 is equal to 0.35. Now, if you apply the addition rule more technically, if you follow the rules of the addition rule, this would be probability of orange, 5 divided by 20, or 5 over 20, plus the probability of blue, 2 over 20, and that would add up to 7 over 20 and 0.35. Now, if 2 gumballs, part B says if 2 gumballs are selected at random without replacement, what's the probability they're both red? The probability they're both red is the probability the first is red times the probability the second is red. Well, the probability the first is red is 6, because there's 6 divided by 20, 6 out of 20. But then the probability the second gumball is red is going to be 5 out of 19, because we're not replacing. We are assuming that first gumball is red, so there's only 5 gumballs that are red left, and there are only 19 gumballs left to choose from. So that probability is 5 divided by 19, and you multiply that by the 6 divided by 20, and you get 30 over 380, and that's approximately 0.0789. That uses the multiplication rule. The probability of one event and another. Alright, and part C says if one gumball is selected at random, what's the probability that it's not green? Well, you can look at this in a couple of ways. You can just look at these and say, well, there's 20 gumballs. 3 of them are green, so that means there's 17 that aren't. So you can just divide 17 by 20 for a probability of 0.85. Or, if you want to use the rule of complements more technically, correctly, then the probability that the gumball is not green is equal to 1 minus the probability that it is. So that's 1 minus 3 over 20, because there are 3 gumballs, so 3 divided by that are green. So 3 divided by 20 is the probability that the gumball is green. So that's 1 minus 3 over 20. 20 over 20 is 1. 20 over 20 minus 3 over 20 gives you 17 over 20, or 0.85. Now, question 3 There were a couple of question 3s. This is the one that's most like the one on the test. Among the contestants in a drawing are 45 women and 30 men. So that means there's a total of 75 contestants. If 4 different winners are randomly selected, what's the probability they are all men? Different implies that they are selected without replacement. So the probability the first contestant is a man is 30 divided by 75, 30 over 75. Then, just like we did in this example with the red gumballs, we now only have 74 men to choose from, and we assume that that first contestant is a man because it asks what's the probability they're all men. So we then multiply the first probability times the second, which is 29 divided by 74. And we do the same thing for the third probability. There's 1 fewer men, 28 now, to choose from 1 fewer contestants, 73. And the same thing with the last probability, 27 divided by 72. And when you multiply all those numerators, you get 657,720 for your numerator. And when you multiply all the denominators, you get 29,170,800. Divide those two, and you have approximately 0.0225. So that's the probability they're all men. The fourth question, we have a table that classifies people. It could be objects, but in this case it's people, in 2 ways. One by gender, and the other by age group. And there will be the fourth question on the test will be exactly like this, with a table like this. Probably fewer categories, but it'll be a table just exactly like this. So if in the table shows a random sample of motor vehicle deaths. Excuse me. And it asks if one of the 623 motor vehicle deaths is randomly selected. Find the following probabilities. First is the probability that a man is chosen. Well, there are 426 men. 426 men out of 623 total people. So 426 divided by 623 is approximately equal to 0.684. Part B asks, what is the probability that this is a man and he is in the age group 75 to 84? Excuse me. Well, there are only 73 people who are men and are in the age group 75 to 84. And so that 73 divided by 623 is the probability that this person, a randomly selected person, is a man and is in this age category. 73 divided by 623 is approximately equal to 0.117. Part C asks, what is the probability that this person is a man or they're age 75 to 84? Well, this is where the removing the overlap comes in. There are 426 men, that's this top row here, and there are 113 people in this age group. But if we can't count this 73 twice. So we have to remove it once. So 426 includes that 73, so there it is, 426 divided by 623. And the 113 includes this 73, so we add that in, 113 divided by 623. Then we have to subtract 73 from one of these. And so we subtract 73 once. So this is 73 divided by 623. And the total then in the numerator becomes 466. 466 divided by 623 is approximately equal to 0.748. Now the last, or no, it's not the last, but part D, part D says, what is the probability that this person is a man given the fact that, and that's what this vertical line means, given the fact that he is in the age category 75 to 84. Well, as soon as you see that line right there and know that it means given this certain condition, given this fact, then that means that we are restricting ourselves to just this age group. Given the fact that he is in this age group means that we are only thinking about these people right here, only this group. So we're only selecting out of 113. But he is a man, and so that means he's one of 73 we're choosing. 73 out of 114 is approximately 0.646. And part E says if 3 different motor vehicle deaths are randomly selected, find the probability they're all male. And this is exactly like this question, number 3, with the contestants in a drawing. We reduce the number that could possibly be chosen from the total number we're choosing from by 1 for each probability. So there's 426 men out of 623, but then in the second probability there are only 425 men left, and there are only 622 people left to choose from. In the third probability there are only 424 men left out of 621 to choose from. And so when you multiply all those numerators and all those denominators, you get a probability of 0.319. And finally, from chapter 4, very sorry about that. Question 5 says a website has the following restrictions when a username is created. Username has to be 10 characters in length. First character is a letter, and the last 9 characters are any letter of the U.S. alphabet or any digit from 0 to 9. How many different usernames are possible if the username is not case sensitive? Not case sensitive means that J. Smith, all lowercase, is the same as capital J, lowercase s, capital M, etc., etc. Okay, so that's what case sensitive means. Well, in the first character, we can have one of the 26 letters of the alphabet, so that's why 26 is in the first place. But then for the next 9 characters, we have a possibility of 26 letters in the alphabet plus any digit from 0 to 9. And there are 10 digits from 0 through 9, because 1 through 9 are 9 of them, and 0 is the 10th. So you add that to 26 and you get 36. So that second character can be 36. But then the third character can be 36 as well. So we multiply by 36 again. The fourth character can be 36, and so on. Well, there are 9 of these 36s lined up, multiplying by one another. And so the compact way of writing this, the factored form, is 26 times 36 raised to the 9th. Now, if you multiply this out, then you will get a number that will be so large your calculator will not be able to contain it, and it will state the answer in scientific notation form. You might have an EE. It depends on the kind of calculator you have. But you do not need to do that. This is the best way to represent the answer right here using the factored form. Now the difference in part B is that in the first character we don't have 26 choices, we have 52, because in this case the username is case sensitive. So all of these 3 versions of J. Smith are different because the lowercase and capital letters are in different places. So that means that the first character would have not just 26 letters to choose from, but 52 characters, because we could have the lowercase a or the uppercase A, the lowercase b or the uppercase b. So there's twice as many, so that means there's 52 characters in the first character, 52 choices in the first character, and then the second character is that same 52 plus the 10 digits from 0 to 9. So that's 62. But then exactly like we have in this case, in the 26 times 36 to the 9th, we have 9 characters with 62 possible choices. So you multiply 9 of those 62s together and you represent that most efficiently as 62 to the 9th. These answers, the factored forms, will be the best way to represent these, because again the numbers will be too large for your calculator to represent without scientific notation. Alright, so that's the first part of the exam, the first 5 questions, and those are all from material in Chapter 4. I'm going to stop this right now and upload it, and then go on to the second half.